Right, how inappropriate extra gang for your bank sounds. I don't think these two words should be used together in the same sentence. Hi, I'm Matt and this is Not Enough Tech. Let's say you are brave enough to invest in a smart light switch just like this one. I've done that, and I went a step further because I'm actually, instead of having just a single gang smart switch, I went for a double gang one despite having just a single light in a ceiling. Why? I'm here to convince you that n+1 is the correct number of gangs that you should be using in your wall. Why? Let me show you. Let me walk you through the functions and I'll tell you why I probably should have invested in a 3-gang socket like this instead. So first of all, the spare gang is linked to my lamp. Lamp is linked via a smart socket and I can operate it with a wall switch. It's clever. Because I really like squeezing functionality out of IKEA dimmer switches, I decided to map a couple of very useful functions. First of all, I obviously want to control the main light and the lamp itself, so I have a 0 for main light and 1 for the lamp. Now, because I have an automatic feature, which means as soon as the projector is connected to internet, it will turn the lights off, I wanted to have an override possible for my lamp. Which means when I press the 1 and hold it, it will trigger the override and the projector won't turn off my lights. Lastly, I have a timer. You can set number of minutes, and when you hold the 0 button on the IKEA dimmer, then you'll switch the lights on and set a timer. The timer can be anything from 1 minute to 1 hour, it's up to you. Oh, it will work with both lights as well. I looked up online what is designated 3 boards and I found the pinout. So the pinout is as follows. There is a VCC and ground, and then RX and TX pins in here, and also GPIO 00 for flash. With that knowledge, I started to solder things out. Be very careful and try not to solder the pins connect them accidentally to a metal shroud, otherwise you're gonna cause a short. In a corner you see a guide to Taskmatizer, but it's as simple as connecting it to a computer and pressing flash. This is the Node-RED section, so let's start with overview. In here you'll see how the extra gang works with my smart socket. In here I'm using an IKEA dimmer to control it. I have a timer which you can set using the IKEA controller. And I have a projector which is connected to internet and I can trigger automatic lights off. And lastly, I have smart assistant set up with Alexa Home and with Nora Node to control Google devices. So let's start to look at this in details. We're gonna start with actually hooking up the spare gang. So in here I've got power 1, that's my extra spare gang, which I translate using the bool set or change node, so I'm translating on and off messages to true and false. Those messages are actually stored in a local variable, in a flow variable bedroom lamp for this in particular. So I have a bedroom lamp in here and that's always true or false. If your smart socket requires different payloads, you can just modify it. Now that information is then relayed back to my smart socket, which also runs Taskmata, and I'm just passing it false or true to change the state of the relay. Now this is the only this particular flow is the only part when I'm actually going to be directly influencing my smart socket, because other than that I will be controlling the light switch which is flashed with Taskmata. Now, because I want those updates to apply to both gangs, I also use the second gang and I'm controlling or actually receiving the information from that topic and changing that to true and false boolean, and then sending that as my flow variable, and in this case it's a bedroom main. So these two will basically make sure that my bedroom main and bedroom lamp, they always going to be set to correct values. I've mentioned I have IKEA dimmer setup, so let's take a look at this. The IKEA works using Zigbee to MQTT, and I have CC2531 USB stick plugged into my Raspberry. Now, when you use this setup, then your payload click message is going to be on, off, brightness up and brightness down, depending on what you do. If you click 1, meaning on, I'm going to toggle my lamp. And I do that by reading the value of my bedroom lamp, so in here, and then responding to it. So if it's set to false, I'm going to set the message payload to true, update my values, the flow variables. In this case, there's a bedroom lamp and a bedroom lamp override. I'm going to explain the override in a moment, and send that message forward and update the wall switch gang #1. Note that I don't update the socket itself because I want to display correct LEDs as well on my wall socket. So if I'm gonna update the wall socket, then the wall socket's gonna trigger this flow and update the smart socket accordingly. Now if I press the 0 on my IKEA switch, then I'm going to trigger main toggle, and main toggle works in exactly the same. It takes the value of the bedroom main and reverses it. So if I've got value false, then I'm going to return the payload true, etc. And I'm gonna mention override in a moment. Now, because I have automatic shut off with the projector, I've used the lamp override, and what it does is when I'm holding the button 1 to trigger the brightness up action, it will ignore my projector switch off commands. And the way it works, it's basically I have a projector ping, so I'm pinging my projector every 7 seconds, and if that ping has a value which is bigger than 0, then it means projector is online and it will switch my lights off. So as you can see, I'm just gonna assign the false payload, and I'm gonna toggle my 2 lights. However, if that ping is none, not a number, or has a different undefined value, then it's false, my projector isn't online anymore, and I don't want anything to happen. And because there would be a problem with this not triggering properly, I had to introduce another value, which is this one, flow bedroom lamp override. Now it means if this value is true, then the messages from projector ping to the ping action, they're flowing without any problems. If this value is false, then the messages are stopped. And to stop these messages for flowing and triggering that automatic shut off, I have a lamp override. This lamp override will set the light on and also will set the bedroom lamp override to false, preventing the messages from ping going forward. So that's why I have a lamp override in here, and that's why the override is cancelled when I use either of the buttons. So when I toggle the lamps or the main lamp or main light in a normal way. Last action on my IKEA, it's the timer, and it's triggered when I hold 0 for more than 1 or 2 seconds required to start the brightness down action. Now, when this is triggered, what I want to take is the current number of seconds, or milliseconds to be precise, and take the timeout. The timeout is how many minutes, in this case you can see the timeout is 10, how many minutes it will take to turn off the lights automatically. Now, because I'm working with milliseconds, I have to multiply this by 60,000 and then add the second value to create a time in the future, which is 10 minutes ahead. Now, once I've got this time in the future, then obviously I want to set the timer state to true, which means that the timer has been armed, and the timer itself to the value, which is going to be number of seconds in the future. And once this is done, then I have to have something to monitor this. To monitor it, I've got a timestamp that's going to be injected into my function node. In a function node, if my timer has been sent, so my timer state is true, then I'm going to compare if the time now is bigger than the timer, then I have to trigger the lights off and reset the timer. So I'm going to trigger the lights off by submitting payload equals false, then setting timer to 0, timer state to false, and then bedroom lamp override to true just in case, because I have a way to reset it, so I should include this here. And I've mentioned that you can configure the timeouts, or there is a short node in here which if you enter the number of minutes, it will basically store that as your timeout. Lastly, I've used Smart Assistant integrations, and I have two integrations in here. I have Alexa and I have the Google integrations. For Amazon devices, I've used the Alexa skill. So just go look for the Alexa skill in the description and of this video in the article, and you'll find exact instructions how to set up. And for Google devices, I have the Nora, which is relatively new, and it's a replacement for gibberish. Because both of them I'm actually responding with true and false, I don't have to do anything, just pass the messages over to my wall switch gang 1 and one switch gang 2 respectively, create a device, mark them as the lights, and you are all set. Everyone watching my channel probably seen this video of me installing smart curtains, and this is main reason why I should consider a 3-gang function instead of 2. So I could control 3 different light sources: main light, lamp, and curtains. It would be so much easier to have them only in one place, and it's so much cooler than actually using the remote or voice commands to control the curtains. So what do you think, guys? Is it n+1 the correct number of gangs that you should be using in your wall switch, or you should be more traditional and just to get a single one for a single light? If I've convinced you, let me know what would you use it for in the comments to this video. There is a link in the description of this video containing project files and detailed instructions, so go ahead and visit that link. As usual, guys, I do not have a posting schedule, so if you're interested in my videos, obviously use the YouTube notification system for that. But if you are interested in articles as well, because not all of them come with a video, then follow me on social media and you will get instant update whenever I publish something new. Thanks so much for watching, guys, and I'm going to see you in the next video. Take care. Bye. It's the bottom. Oh, God.